This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software. Are you ready to take the next step in your career as an engineer? Penn State, a leader in engineering education, offers an online program that lets you earn your master's in software engineering without leaving your current position. You can complete your degree in as little as 2 years, and GREs are not required for admission. Learn more by visiting us at worldcampus.psu.edu/SERadio.
Hello, this is Jeremy Jung for Software Engineering Radio. Today I'm speaking with Tyler McMullen. Tyler is the CTO of Fastly, where he is responsible for system architecture and leads the company's technology vision. Previously, he worked on text analysis and recommendations at Script. I'll be speaking with Tyler about what a CDN is, why and how a project would use one, and what goes into its creation. Tyler, welcome to Software Engineering Radio.
Thank you. Happy to be here.
Let's start things off by defining a content delivery network.
Sure, yeah. Content delivery network, at its core, is really a geographically distributed network of servers that serve the content for a website or an application.
What kind of information can be stored in a content delivery network?
Well, really, it could be just about anything. For most CDNs out there, it's really anything that can be delivered over HTTP. That could be videos and images, CSS, all the way to actual web pages and APIs and all sorts of things.
If it can store pretty much anything, how would you differentiate the role of a CDN from object storage, like, for example, S3?
Sure. Now, so something like S3 is much more focused on making sure that an object will always be there, right? If you lose an object in S3, that's a huge problem for them. Whereas Fastly, one of our big benefits is that, if push comes to shove, we can actually lose objects, right? It's a cache rather than an actual storage system, a database, right? What we focus much more on is making sure that the delivery of the objects are actually really fast.
The main differentiator is the fact that you don't have to worry about losing it because you know that the data will always be there to retrieve again if you were to lose it.
Exactly. The way that our CDN works, and this has changed over the course of years. I'm sure we'll get to that later. But we function as a proxy, right? So we are not supposed to be the actual primary storage for really anything, right? So we function as the server that sits in between you and your customers.
And you were saying that since this is more of a cache type of situation, how would you distinguish what Fastly does or CDNs do compared to something like Memcached or Redis?
Yeah, so it's similar in a lot of ways, right? At its core, they're both there to try to make the delivery of the application, the delivery of the content itself faster. Something like Memcached or Redis, though, is much more focused on being available during the generation of the content itself, right? They're also not write-through or read-through caches. So Fastly and CDNs in general at this point really function as a read-through proxy cache, right? So a user might, request some particular piece of content from your site. We get that request. If we don't have it, we'll then go look it up. And then the next person that comes along, we won't have to go look it up because we'll already have it.
Next, I'd like to ask, are there any common misconceptions about what a CDN can or can't do?
Well, there's a variety of these. I hear these all the time, actually. Probably the biggest one, I would say, is there's always this conception that a CDN is actually supposed to be pushed to, kind of like what you would expect from something like S3, that is the primary storage for a thing. And to be clear, there have been CDNs that function like that in the past. That's really an uncommon model now, though. So one of the interesting effects of that is that if it's supposed to be a proxy, if all your users can read through it, that actually puts us in an interesting place, right? So we can actually serve things that aren't cacheable, right? So dynamic content as well can be served just the same through a CDN, as long as that CDN provides you the ability to distinguish between cacheable and non-cacheable things.
You were saying that in the past, there was this perception that CDNs were supposed to be pushed to. Why was that not a good idea, or why have things changed now?
So I think a lot of it comes down to how the internet, how websites and applications are built these days. in the past, the internet and websites were a lot more static than they are now. You would have your HTML, you wrote your HTML, you pushed your images, you would push your, well, not even CSS back then really, but all sorts of things like that. And, that site was fairly static until you decided to change it. Now we have a lot more in the way of like user-generated content and dynamic content in general, right? So it makes a lot more sense to allow the CDN to fetch new objects and new things that didn't exist before, right? Without you having to actually go actually push them up to the CDN.
Just because nowadays things are more frequently changing on the websites.
Right. If you can imagine like a large social network, if every time a post was made, they had to actually push that post to a like global network of servers, that would be like extremely non-scalable.
Right. Okay. Another thing I'd like to define before we go further is the idea of an origin and an edge within the context of CDNs. Could you describe that?
Yeah. So an origin in our case could be anything from like a single server that you're hosting on, some Linode or something like that, all the way to like a multiple data centers that you as one of our customers have hosting in like AWS all around the world, for instance. So the origin is really just the source of the content. We look at the origin as being like the source of truth, right? And the edge for us, anyway, is our data centers spread around the world, right? I think the edge is kind of an interesting topic at the moment, just because there are so many different definitions that people use for it. But from our perspective, anyway, the edge is our 50 plus data centers spread around the world.
Basically, the user's application would be the origin, and the edge is the CDN, which is retrieving all of the canonical data from the origin.
Sure. And even that is changing, though. Now with like a lot of what is going on with new development in CDNs and, at the edge in general, there are certain cases where we're actually starting to use the edge as the origin itself as well. But I'm sure we can get into that later.
Yeah, for sure. We'll have to remember to come back to that. So another aspect of CDNs is when users request data, they're hitting a host name. So one of the things that I want to talk about is DNS. So first off, could you give like a high level overview of what DNS does?
Sure. So probably the most common metaphor that's used for DNS is the idea of a phone book. So if you wanted to look someone up in the phone book, or if you wanted to call someone effectively, you would look them up in the phone book and you would go, all right, well, let me see. I will look them up by name and I'll get a number for them. Well, that's not so different than the way DNS works, except in this case, that phone book is in fact hosted by your ISP typically. And so when you want to find a site, let's say you're trying to go to fastly.com, you would your computer would actually send a small packet that would go out to the DNS server that your ISP is hosting. That ISP's DNS server, if it knows about it, would have just immediately respond with, all right, here are the IP address or the IP addresses that I know of for that site. And if it doesn't, it actually is itself yet another reverse proxy, and we'll go look it up for you and then remember it for the next time.
And as a developer, how do you configure a website to serve content from a specific domain?
Okay, so this is actually like more complicated than it might seem. But like the typical way this is done is that, if you have a subdomain, let's say it's www.yoursite.com, you would actually set a DNS CNAME on that. You tell your DNS provider that you want to put a CNAME record for that particular subdomain. And that CNAME would then essentially, effectively, it's similar to an HTTP redirect. You say, okay, this website is actually going to be pointing to this other website, right? And then your DNS resolver, your ISP's DNS resolver, would then do that recursive lookup to see, okay, here, what is the IP address for the redirected domain? So in our case, that would be, you're going to prod.fastly.net for your site. And so, your DNS would go look up prod.fastly.net, which would then provide an IP address. And like, this is actually a big portion of how CDNs are able to do geographic distribution well, is the fact that when your DNS provider goes and looks up, okay, what is prod.fastly.net? It will get a different response depending on where you are in the world.
What's making the decision on which server to pass you to when you make that request? Like where does that part live?
Right. So as part of the DNS lookup, it ends up eventually, if you have that CNAME pointed to prod.fastly.net, for instance, that ends up eventually hitting one of our servers. So we have our own DNS servers that will sit there and go, okay, well, if this DNS request is coming from such and such location, well, I know that the closest place that I can send that user is actually over here, right? So if you're in LA, for instance, you would end up getting an IP address that is one of our data centers in LA.
Okay, so it's actually a DNS server that's managed by Fastly.
Oh yeah, absolutely.
Okay. Next, I'd like to discuss why someone would use a CDN. So for one of the reasons would be the performance. So first off, how can a CDN improve performance for someone's application?
So like at the most basic form, the way the CDN works is that it improves performance by making sure that when a user requests a particular piece of content, that piece of content is close to the user already. So this is especially important. Like it's important even inside the US and inside like other like highly developed countries. But if you're or not even highly developed countries, but countries that are close to the origin. But it applies even more if you're in some place like Australia, right? If your origin server is, say, in Ashburn, Virginia, and your user is coming from Australia, well, okay, if you want to get a piece of content that is, especially a large piece of content, right, that's going to involve quite a few round trips back and forth. And the speed of light is fast, but it's not infinitely fast, right? So it can end up being quite a bit faster to be able to just get that piece of content from somewhere that is right next door to you. And so there's a bunch of different ways that actually makes things faster, right? So part of it is just network latency, right? But then if you consider the fact that, especially in like the internet as it exists today, like the time it takes to generate that content might be non-trivial, right? And so that's where the cache itself comes in, right? So if you're able to then just serve a piece of content that is already static at this point, it's just sitting there on one of our servers, that's, in addition to the network optimization portion, it's also quite a bit faster just because you don't have to generate the content. And then furthermore, if you have a piece of dynamic content, right, where in the case that, let's say it's like something that's personalized to that particular user where you can't actually cache it or it contains private information or something like that. If you pass that through Fastly at least, and this isn't the case for all CDNs, but one of the things that we do is we keep a connection open to your origin. And so this ends up coming back to like, fairly basic like TCP optimization type of stuff. So TCP has this concept of slow start. So if you send an initial request, you open your connection with TCP, you can only send a few packets initially before you then have to wait for an acknowledgement, right? And so over time, that window, that TCP congestion window, will increase up to a certain amount. That certain amount should be roughly near like what your total bandwidth is that's available between you and the origin server. So what we do effectively is, if you're going for a piece of dynamic content, you'll go to the Fastly server that is nearby you, and then we will have a connection that is already open back to your origin server. So you're not having to wait for that TCP congestion window for nearly as much time. So even just network optimizations themselves can make a pretty huge difference.
In terms of like a rough metric or percentage, how much faster have you seen CDNs make a application?
Well, again, this is something that really is super application dependent.
Sure.
Right. But we've seen things where, sites go from like 20-second, 15-second load times down to 2 or 3 seconds.
Wow.
Right?
Okay.
So it can be massive. Right. And so much of this is also like geographically dependent as well.
And in terms of whether it's the latency being improved or the data being served statically or the TCP slow start, which part makes the most difference is going to be dependent on the application too, right?
Oh, yeah, absolutely. So if you have like a particularly slow origin server, like, one of our major customers in the early days was a large wiki. And, it takes a long time. Like those PHP-based wiki servers, they have a lot of work to do to be able to generate all the content on a particular page. And so like that was a great example of like, all right, we can just serve this static content that is static until it changes, of course, directly from the edge without having to do all of that generation.
How can using a CDN improve reliability? And can you also explain how the CDN itself is redundant?
It's a really interesting question, actually. Like the way that a CDN increases reliability is the fact that like the CDN itself is like, the way I like to think of that is the CDN is actually fairly simple, right? Like when you're just delivering content, when you're just delivering static content, there's no database lookups. There's no, we have fairly few things that can actually go down on one of our servers, right? But really what it comes down to is the fact that, that helps a little bit, right? Like the fact that we're just delivering static content in most cases. But what helps the most is just the fact that we have thousands of servers spread around the world. And so we actually have multiple layers built into the network to prevent an outage of a single server or even a single data center from even being noticeable by your users. So part of that is DNS, right? So, as I was saying, the DNS request that ends up coming through from your end users ends up hitting one of our DNS servers, right? That DNS is actually served via something called Anycast. So what this effectively is that, we have a single IP address, which is actually served from multiple different locations, right? So we have many locations around the world saying like, hey, I have, via BGP, I have this IP address, you can get this from me. So if a data center goes down, that DNS request will actually just be routed by BGP to someone else. Furthermore, if a data center went down, we also know that internally inside our network. So we can just say with our DNS server, like, this one's down, let's send them to the next closest server. But beyond that, we also have redundancy built into the data centers themselves. So if a single server goes down, that's actually noticed by our switch itself, right? And so we have a monitoring system that runs on the switch with, in collaboration with a piece of software that's running on the server. And so when a server stops responding, when a health check fails for the server, we actually just remove it from the switch entirely. And so any content that would have been requested from that server will then be routed to a different server within the same data center. Moreover, we also store the content multiple times within a data center. So the failure of a single server, not only will the request still be served, but it'll still be served with roughly the same speed as well.
So you've got the data stored in multiple places for redundancy. You've got servers kind of all over the world in terms of spreading the redundancy that way. And then at the data center level, you also have monitoring to make sure that none of the data centers are affected by servers going down.
Yeah, exactly. And like that type of monitoring needs to be, sub-second kind of like response time. So when a server goes down, we know immediately. The thing is, when you're serving like 5 million plus requests per second, like even 1 second of downtime is a lot of requests.
Right. I want to go back briefly to, you were describing Anycast. Just so that I make sure I understand correctly, you were saying you could have a single IP, and when, say, my ISP starts to perform a DNS lookup to that IP, then it could actually go to any one of your servers that are, located throughout the world.
Yeah. At its core, and I'm sure our network engineering team is just going to hate me because I'm sure I'm going to butcher the description of Anycast here. But effectively, what you're doing is you're advertising via BGP, the Border Gateway Protocol, that any of these data centers can serve this particular IP address. And what ends up happening there is that on the intermediary routers between that, the router will be able to figure out, all right, well, I have multiple routes I could take to get to this particular IP address. Let me take the one that has the least number of hops. And when we say hops, we don't actually mean hops in terms of IP addresses along the way. We actually mean hops in terms of AS numbers, that is autonomous system numbers. So Anycast is a great way to like provide redundancy and provide like failover capabilities, but it's also like it's a blunt instrument, right? So it's fairly hard to direct traffic accurately using Anycast.
At a high level, when you say autonomous system, what are you referring to there?
So an autonomous system number basically just describes an entire network, right? So when you say that, like when you do say a who is on a particular IP address and look up who owns that, that's actually looking up what the AS number is of that IP address and then whose information is connected with that AS number. So Fastly has one AS number that we use for all of them.
Okay. Next, I'd like to talk about how a CDN might be able to improve security. Can you give some examples of security-related features that a CDN can provide?
Sure. So there's actually a bunch of these. I mean, probably the most obvious one is DDoS mitigation, right? And part of this actually just comes down to like the basic architecture of a CDN, like the fact that we are sitting in between your end users and you and your origin server means that any attacks that, like, let's say, SYN floods that would normally be hitting your origin server would be hitting us instead, right? So we sit there kind of as a shield to all those sorts of attacks. But it actually goes beyond that, right? So when you have, some CDNs, specifically Fastly, has the concept of a web application firewall, right? So what that ends up meaning is that requests that are flowing through the system, we can also then check against all sorts of filters to look for common sorts of attacks, be that a SQL injection attack or really anything.
And so you can check for those and block them before the origin system even ever sees them?
Yeah, exactly. And that's even more true for the DDoS mitigation, right? So like in the case of a SYN flood, you wouldn't even see any of those. You wouldn't see a single packet, right? Because in the case of a SYN flood, effectively what the attacker is trying to do is open a ton of connections. However, those connections aren't real. They're fake connections. And the whole idea behind a SYN flood is that when you open a connection, when you send that SYN packet initially to a server, that actually takes up some state in the server's operating system. And that state is essentially saying, okay, I have this person on the other end that is looking to open a connection. I'm going to be like, I'm going to do the handshake with them now. So it has to remember that. And so when you then suddenly send hundreds of thousands, millions or more SYNs, this can actually cause like quite a bit of strain on any particular server, right? So Fastly has mitigations in place for that. So we can handle those sorts of attacks, and you would never see a single one of them.
Are there any ways that introducing a CDN can actually increase your attack surface?
Well, I mean, yeah, certainly. It's anytime you, I feel like any software engineer realizes that, anytime you introduce a new dependency into your system, like it changes your attack surface at the very least. Like the ultimate goal here is that, like, when you use a CDN or use really any third-party system, that effectively you're reducing your attack surface ultimately, but you're introducing a new attack surface, right? So yeah, I mean, if you look at like certain incidents that have happened in the past, it's certainly possible that bad things can happen. But we do all sorts of things to prevent that. We have an entire security team that is like constantly attacking our system by themselves to find any sorts of holes that would be found by attackers.
Most high-profile security incident I can think of with CDNs is the cloud bleed bug, where there was a memory leak issue and things like cookies and API tokens were being leaked by edge servers. So I just wanted to get your thoughts on that.
Sure. I mean, that kind of thing can happen to anybody. But, it's just a matter of, what your response is to it when it does happen, and, just doing everything you can to prevent it ahead of time.
Right. So in the end, it's anytime you use a managed service, you're placing some level of trust in the system. And so. Yeah.
I mean, if you think about it, like, it's really a question of like who, how much do you trust, like how much do you trust any third party provider? Like, someone like Fastly is sitting between you and your users. Like, we put a lot of effort into making sure that nothing bad can happen there. We don't always succeed, but we probably succeed a lot more than, the vast majority.
The next thing I'd like to go into is the different ways that a CDN can be used. So let's start with static asset caching. Can you describe how somebody that has a dynamic site now would get started with using a CDN for that?
Sure. So there's many different ways that you could approach this, right? Like the way that I would typically suggest is that, you're probably serving your static assets and your dynamic assets from the same domain. It's a small site. And in that case, like the easiest way to do this is really just to change the entire site over to point to the CDN. And, the important part with this, like the really key part is, so you set up your DNS, but like the most key thing is making sure that the HTTP caching headers that you're using are correct, right? So if it were the case that like you were serving dynamic content that was personalized and the HTTP caching header said to cache it, that could be fairly dangerous, right? So I would say that one of the first things you would want to do is make sure that your caching headers are set up correctly. The alternative, of course, is that you could set up a separate domain that is used specifically for serving static content. And there are certain advantages to that as well. Like specifically, that typically, like if you have a dynamic site, you're using cookies, you're using all sorts of things that like actually bloat the initial like request and responses. By using a separate domain for that, you can actually shrink those down and optimize them to the point where it's just the bare minimum that's required there. So that's actually the primary reason why people use separate domains for that. Is really just to make sure that like, all right, so if I'm using enormous cookies on my dynamic side of my site, those don't have to be sent and received every single time I send a request for, a single CSS file, for instance.
Okay. So that would be the main reason why you would choose to have a different domain.
Yeah, that's the biggest thing. I mean, the other thing was, there was always the use case in the past where people would set up many different static domains. So you would see like static.whatever1, static.whatever2. And this was actually an attempt to get around HTTP's head of line blocking. But as it turns out, if you're using HTTP2 or eventually Quick, this is actually not even necessary because the head of line blocking problem basically goes away.
And you were describing that initially you would recommend that someone change their entire site over to being backed by the CDN. But you were also talking about dynamic content. So in that case, how would someone set up their site to be served entirely from the CDN, even though they have dynamic content?
Sure. I mean, the key thing to do there, again, this kind of comes back to the HTTP caching headers. So it's knowing, as you're generating that content, okay, this piece of content is dynamic versus this one being static. The dynamic one you would want to then set to be private, no cache. And there's all sorts of great articles on the internet about how to set that up correctly with the cache control header. That's really the key thing there, though. Yeah.
And so when we're talking about dynamic content, this could be things like API calls as well. So somebody makes a call to, say, a JSON API, and as long as the HTTP headers always return no cache, then that should be okay. Yeah,
that should be just fine. And this is like kind of a great intro to like one of the things that Fastly does quite a bit different than most other CDNs. So what a lot of people consider to be dynamic content, I would argue, is not actually dynamic content. So if you're talking about something like user-generated content, again, kind of going back to the wiki example that I was giving before, that content is not actually dynamic. It's static until someone changes it, right? Kind of in the same sense as like everything else is static until someone changes it. And so one of the key things that Fastly provides is this ability to remove content really rapidly from around the world. So we have a purging system, right? So essentially the idea with this is that, you can cache those, supposedly dynamic pages until you know that they change, right? So if someone updates that page, if someone posts a new comment or whatever, this gives you the ability to then, in about 150 milliseconds, remove that piece of content from around the world, which will then let us cache the new version.
When you talk about static content from the perspective of the CDN, that's content that...
Yeah, no, it's content that is... I mean, probably the key way that I think about it is that it's content that is reusable, right? Even if that content changes frequently, if it's reusable across different users, across different requests, that content is effectively cacheable.
What about content that is restricted per user, content that only someone who's authenticated with the page should be able to see?
Sure. So there's a couple different ways to do that. Like, the most common way, if you're using a basic CDN, would be to treat that content as dynamic and not cache it. You can do some more interesting things, though. For instance, we have quite a few customers who actually do authentication in the CDN, which is kind of an interesting use case, I think. So they can do that by validating that the cookie that is on that request is correct, is valid. Actually put that logic in the CDN itself. Or you can even do like weirder things. And we can do this. So Fastly has a concept of multiple requests that we make to your origin for a single request that a user makes to us. So what we can do is the user makes a request for something that needs authentication. We then send a request back to your origin saying, hey, is this user valid? And how long are they valid for? And then we remember that. We cache that in the CDN the exact same way we would cache anything else. And then we can go, okay, now we know that this user is validated, is authenticated. So we can just serve them the content that we already have cached.
So does that mean that Fastly is actually has some kind of state to keep track of these users?
So kind of, yeah. I mean, you could think of it that way. I guess the way I think of it is from the inside of the CDN, right? Like I know how the sausage is made, and so I effectively think of this as just it's making multiple requests back to the origin and caching them in the CDN the same way we would cache anything. So we're just caching the authentication, but effectively, yeah, it's remembering state across requests.
Okay, and this sort of authentication back and forth, that could be through cookies, or that could be through some other method.
Sure, it could be through cookies. I mean, effectively, really what you need is just an API on the other end that knows whether or not a particular cookie is valid, is authenticatable.
DigitalOcean is the easiest cloud platform to deploy, manage, and scale applications of any size, removing infrastructure friction and providing predictability so developers and their teams can deploy faster and focus on building software that customers love. With thousands of in-depth tutorials and an active community, we provide the support you need. DigitalOcean stands out of the crowd due to its simplicity and high performance with no billing surprises. Try DigitalOcean for free by getting a $100 infrastructure credit at do.co/SERadio.
Next, I'd like to talk about developing an application with a CDN in mind. The first question would be, does the introduction of a CDN to a project impact development? Are there things that the developer needs to do differently in order to add a CDN?
So I think the biggest thing with this is making sure that content that is cacheable, that is static, or at least temporarily static, is separated as much as possible from content that to be private or dynamic. So if you had a single web page that had everything built into it, including the dynamic and the static content, well, that's going to be hard to cache because we can't really separate out what is static and what is dynamic from that. So if instead, what you can do is break that up into multiple requests, into multiple responses, such that we minimize the number, the size especially, of the dynamic content, and instead break out the static content into something that can be cached. That makes a big difference there.
In this case, it would be breaking out the dynamic content into separate API calls. Is that kind of what you had in mind?
That's kind of what I have in mind, yeah. So, a really simple example of this is we have lots of media, like newspaper kind of websites that use Fastly. And a lot of times what you'll see when you initially go to those sites is that it's actually the same. It's the same for the vast majority of users. And the only difference is that, at least initially, at least visibly, is that your name is in the top right corner, right? And so if you were generating that entire page with just that little bit of private, user-specific content there, it's easy to make the entire page non-cacheable. If instead you can break that out into a separate API call and fill it in later, or even use something like ESI, Edge Side Includes, in order to input that data, then you can make much more of the site cacheable, which improves the user's experience and also reduces the amount of load on your origin server by quite a lot.
You had mentioned ESI. Could you define what that means?
Sure. ESI stands for Edge Side Includes. And so what ESI is it's a little markup language that can be placed into HTML or XML, or you can even kind of abuse it and put it inside of JSON. But the whole idea here is that it's something that the CDN or even your server can then parse. And when it parses it, it finds, this markup right here should actually be replaced with the content from this other page over here, right? So it lets you, you can think of it as a template language that's specifically made for the edge. It's actually been around for quite a while, but there are some certain issues with it. It's one of the problems with this, with ESI, is that it's effectively easy to DDoS yourself with it if you do it wrong. So the way that I would usually suggest to people that they do this is actually just by doing it client side. Let the JavaScript in your user's browser fill in the content that is specifically private to them.
Right. Okay. In the case of somebody having an application where they haven't really built for the CDN in mind, but they just want to get started quickly, what kind of options do they have?
So Probably the easiest. So yeah, there's some pretty easy options they have. The easiest thing is, okay, cool, separate out your static content, make sure that your server is, setting those HTTP cache control headers correctly, and then just accept the fact that like the content on some of those, maybe it's the HTML for your pages, is going to be dynamic. But the neat thing is that you still, as I was mentioning earlier, you still get quite a bit of benefit from the CDN based on those network optimizations that we're doing. So even if your entire site was dynamic, and we actually have several customers who don't cache anything, they're instead like just using us for the network optimization part, you still get quite a bit of benefit.
And in cases like this, are you talking about where someone will go to a site and it'll be hitting Fastly first, or is this the case of where someone hits a site and they're just using Fastly to pull images or other static things that are on the dynamic page?
So, it's really both, right? So if you can specifically set the HTTP headers correctly for the static content, we'll do the right thing with that, which is essentially to like cache just the responses that are actually cacheable, right? So really I know I'm kind of like a broken record here, but like if you set your cache control headers correctly, you can put a CDN in front of it and it should continue to function exactly the way that you expect.
For someone to set the cache control headers, would that normally have to be done by modifying source code, or is that something that could be done as a part of a deployment process?
So it's certainly something you could do as part of a deployment process. I would make the argument that in the source code is actually a better place to do this, though, because you can do things that are a lot smarter. For instance, if you're generating the content and you know that some particular piece of that particular page is going to change every 5 minutes, let's say, you can then set that cache control header to be, cache this for 5 minutes, right? So I think it's a lot harder if you attempt to do that from your deployment process itself. But, in the case that that's not possible, you can do that as well. You can actually do this inside Fastly itself if you really want to, just by looking at, we provide our customers the ability to use VCL, which is, a programming language built specifically for this kind of thing. And so what you can do is just say all right, well, I know as I am deploying things with my CDN, I know that this particular path is cacheable for this long and this particular path is not cacheable at all or whatever. And you can actually just set that in the CDN itself.
Okay. You would recommend that if the developer was able to, they would do it in code because they have more control and more information so that they can make better decisions on when to cache. But it is technically possible to do that entirely from the CDN side.
Yeah, absolutely. It's definitely you have much more information at the origin if you want to set those things correctly there. But, if push comes to shove, it's pretty easy to do inside Fastly as well.
And how can a developer test their application with a CDN before pushing to production?
There's actually a wide variety of different ways to do this. You can, if your CDN supports logic at the edge like we do, you can do all sorts of interesting things. So for instance, you could actually set some specific logic that says, if this particular header or this particular URL parameter is present, well then, use this different logic instead, which would let you then make sure that, okay, when I set this on the rest of the site, I now know that it's going to work correctly. But at the same time, you could actually use DNS for this as well. So if you had a site, example.com, www.example.com, you could then set beta.example.com and have that pointed to a different service within your CDN, or even the same service with a different set of logic for that domain specifically. So yeah, there's we like to, as much as possible, use the basic building blocks that are built into the web itself in order to do things like this. There's no real magic tricks here. It's really just doing basic logic on the HTTP requests and the DNS.
Mm.
Yeah.
So in this case, the developer, they should push to some kind of test or staging environment and set these headers to tell their application, okay, use these settings for the CDN, and then they can check their page that way.
Yeah. There's actually all sorts of use cases for that kind of logic as well. For instance, if you wanted to be able to do A/B testing at the edge, what you could do is you deploy your new code to one particular origin server, and you have multiple other origin servers, and you can actually just say, okay, I would like to send certain requests to this origin server, and I want to send other requests to this origin server, and I want to cache them separately. So if you can do logic at the edge, you can do that kind of testing, that kind of quality assurance, or even A/B testing right there at the edge as well.
Next, I'd like to talk about cache invalidation. I know as a part of our conversation, a lot of it has come down to the HTTP headers. But to make sure that everyone's on the same page, can you explain the concept of cache invalidation and how it relates to CDNs?
Cache invalidation is just removing the content that's in the CDN when you ask for it to be. This has actually been kind of a difficult thing for CDNs for the longest time, just because when you say, hey, remove this piece of content, that then has to be replicated to any server where that content possibly could have been, which in the case of thousands of servers, that could take a while. So one of the novel parts of Fastly was the fast purging system that we built that does it in about 150 milliseconds.
And this purging that occurs when someone's HTTP header says that this content should be expired or should never expire, or whatever they put into the header. Are there other options for users who want to tell the CDN when content should be invalidated?
Yeah. Sorry, I actually didn't realize that you were asking specifically about the cache control header. So that's actually a different sort of thing. I actually think of the cache invalidation as kind of two different things there. That one is actually very simple. We actually do the math, like the time math that's involved with making sure that something is still fresh inside the CDN. So that happens like individually inside each individual node without ever having to communicate with anything else. So that should actually be instantaneous. That should actually, like, if you're setting those cache control headers correctly, that should be completely invisible to you. The other option, though, is actually specifically telling us to purge something. So we have a couple different ways of doing that. One is to just send an HTTP request with, instead of a get or a head or whatever other method you prefer, instead send it with a purge method. And so what that'll do is that will trigger what's effectively a peer-to-peer messaging system inside of the CDN. And what that does is make sure that that particular message gets around to every single node inside the CDN and make sure that that piece of content that you were trying to purge is now gone from everywhere.
So when you were originally answering the question about invalidation, you were thinking more in terms of the API call request to purge. Is that correct?
Yeah, that's correct. The side of things that's talking about the cache control headers is actually quite a bit easier. That can happen just independently everywhere.
You mentioned earlier about the VCL. Could you explain kind of what that is and when you would choose to use that rather than the headers or an API call to the CDN?
Yeah, so VCL stands for Varnish Configuration Language. So Fastly, of course, is built on Varnish. That's what we've been built on all along. And from the very beginning, we gave our customers access to VCL. And so the whole idea with VCL is that you're programming the request response state machine. So what you do is you program individual hooks. So one of them is, I have received a request. So you say like, okay, I have this request now. Let me look at the headers. Let me look at the URL that was requested. Is there any headers I want to change? Is there any caching logic I want to change? How do I decide, or I would like to make a decision to send it to this origin server rather than this other origin server. So when you have that kind of logic at the edge, that gives you the ability to do some pretty interesting things. So one of those is basic stuff like load balancing, right? So I can then say, all right, I have multiple different clusters of origin servers, and I'm going to make the logical decision that this particular piece of content I know is actually on this origin server, which gives you a lot of flexibility to then be able to move your servers around, change where they're deployed, and so on. So when would someone use it and when would they not? It really comes down to, how much control do you want at the edge, right? If you have a fairly basic site, you might not need it, right? You could actually just, you plug it in and it just works. But as soon as you want to do anything that's fairly tricky at the edge, you want to start doing load balancing based on HTTP headers or the URL that was requested, or you want to start modifying those HTTP headers or responses. That is, we would use VCL to do all those sorts of things.
Do you have an example of a customer that used VCL to either do load balancing or some other type of function that you would not be able to do with API calls or headers?
Sure. Actually, I would say the majority of our customers do that. I think the New York Times is probably one of my favorite examples of this. They were able to use us in order to migrate their data centers, right? So they did this just by using the load balancing inside Fastly, right? So they changed where their entire site was hosted, without their customers ever actually knowing.
So let's say they spun up a whole new set of servers or a new origin while the old one was running, and then they configured Fastly using the VCL to point to the new location of their origin servers. Is that correct?
Well, yeah, kind of. I think it's actually even a little bit more tricky than that. So the thing with a complex site like that is that it's never really just one service, right? It's actually many.
Right.
And so this let them do it gradually. You can move one service at a time, and then inside VCL, you can go, okay, like they're requesting something that's in this service. Well, I know that this service is now running in the new data center. So let's go over there rather than having to go back to the old data center. So you can move things piecemeal like that, which is really helps people, especially if they're trying to go with like a multi-cloud type of setup. Right. They tend to put us in front of that as the load balancer between their clouds.
Okay, interesting.
Yeah.
Next, I'd like to kind of go in a little bit into how a CDN is built. So to start, did Fastly build their own data centers, or are they hosted in existing ones? How did that get started?
Great. So I love talking about how the CDN is built. This is where I live and breathe every day. So did we build our own data centers? Well, no, not physically. We co-locate our servers and our racks of servers inside all sorts of different data centers that already exist. So typically what we'll do is we'll rent space for an entire cage of servers at this point. But that, of course, changed over the years, right? When we first were deployed, we weren't even using racks of servers. We were using individual servers. Like we would ship one single server to a new location, right? And just plug it directly into the internet, into the ISPs that we were paying. Now, of course, we get entire cages and racks of servers in each location. Typically, we'll deploy really no less than 8 servers in a location. And in some places we'll have up to 256 servers in a single location.
That's quite a change from when you first started.
Yeah, quite a change.
So next, when you choose a location of where to put your servers, how do you determine that?
Yeah, okay. So this is a really interesting process. A lot of what goes into this is really looking at, of course, like our list of customers, our list of users is changing all the time, right? And so where we have users coming from is then also changing. And so when we decide we're going to put in a new data center somewhere, we then have to go, all right, well, as of now, where are we slower than anywhere else? And where can we find a data center that has the necessary connectivity and we can get into? So what we try to do for the most part is find places with a high population density where there is also a high density of transit, of network transit, right? So typically in one of our data centers, we try to avoid deploying data centers if we can't get at least 3 different ISPs connectivity there. And so a lot of this is really just for redundancy. Like we need to make sure that if level 3 goes down or whoever else, if they go down in that location, that we still have the ability to serve content rapidly from that place, right? So it ends up being a combination of high network density and high population density.
And when a client is routed to an edge server, you were talking about Anycast before. Is it just Anycast, or is there also, custom software or custom hardware within your infrastructure that handles that?
So this is actually a really interesting topic that we're still working on this, right? Like we, despite being around for 7.5 years now, this is something that is a continual improvement process. So the primary thing is, okay, we get this DNS request from some end user, and then we go, okay, well, if this particular server, if this data center got that DNS request, well, then this is probably the closest data center to where they are, to where that user is, right? And that's true in most cases. However, it's not always true. There are plenty of cases where, if you remember, that DNS request isn't actually coming directly from the user. It's actually coming from their ISP's recursive DNS resolver. So there are plenty of cases where a user's recursive DNS resolver is not actually close to them. We have all sorts of fun examples of this. I believe one of them was an ISP in the Netherlands was purchased by an Irish company. And after the purchase, all of the DNS requests for all of the users in the Netherlands started being routed to Ireland.
Oh, wow.
And so then initially we would get that to one of our UK servers. And so we started routing all of the Netherlands, or rather all of the Netherlands on that ISP to our UK servers, right? So not ideal. So there's a lot more that now goes into it. So one of the things that we do is we have beacons on various websites, and effectively what we're trying to do is like map out the internet, right? So if the DNS resolvers are not going to give us all the information that we need, we then have to figure out, okay, if this user is coming from this resolver, let's figure out where that user actually is and try to send them to the correct data center that's close to them. And so we collect some information, anonymized, dramatically anonymized, of course, from our beacons, and are able to then pick out like which data center is actually closest to the user, regardless of what the DNS says. Furthermore, there's actually some modifications to DNS that were made over the last few years, specifically the client eDNS routing system. And so what this does is certain recursive resolvers will, instead of just requesting it once and then requesting that DNS information once and then caching it, they will request it multiple times, depending on where that user is coming from. So, large DNS servers like, okay, let's take like Google DNS, for instance, 8.8.8.8. That can be particularly tricky for us, right? Because they have effectively one data center serving all of the West Coast of the US. It's in Seattle, I believe. So if we didn't do anything smarter with that, we would actually just be sending all of the West Coast that is using Google DNS up to our Seattle data center. So instead, what Google does is, depending on the subnet of the user's request that is coming into them, they will pass that through to us. And this is, again, anonymized information, but it lets us separate out and go, oh, okay, well, this user is actually coming from this other location. So let's send them to their closest data center. Hope that makes sense.
When you're referring to the subnet, you're talking about the user's public IPs, like a part of that subnet, or?
I am indeed, yeah.
Okay.
So typically it'll end up being like what's referred to as the /24 of your IP address, if we're talking about IPv4, meaning that, we have, there are 4 octets associated with an IP address, and they just chop off the last one, which is a reasonable level of anonymization.
And based off of the user's subnet, you have enough information to know kind of where they originally came from, or?
Exactly. So this goes back to that beaconing system where we then go, okay, well, we know that, this block of IP addresses tend to actually be in some particular location, right? And so then when we get one of these client eDNS requests that come through the DNS system, we go, okay, I know where that particular IP address is. I'm not going to send them to Seattle. Instead, I'm going to send them to our San Francisco POP, for instance.
Okay. And you're keeping track of sort of, as people visit all these different sites all over the world, you sort of build a picture of like, okay, if I get a request from this subnet, then I should route them here because this place is close to them.
Exactly. I like to think of it as a map of the internet.
Awesome.
Yeah.
Earlier, you mentioned that you used Varnish as a part of building the CDN. Could you explain what Varnish is and how it's different from, say, Nginx or Apache?
Varnish is an open source reverse proxy server. It was initially built by a guy named Paul Henning-Kemp, who's part of the BSD community. And his whole thing was he was trying to build a very high performance proxy server that was programmable. And so he built this VCL programming language into it. And that's like at its core, the big difference between something like Varnish and something like, Apache or Nginx is the fact that it has this language built into it. And the interesting thing about it is that it's not actually a scripting language like you might expect. The VCL that's written is actually compiled down to C, which is then compiled down to native machine code, which we then load into Varnish at runtime. And what that lets us do is we can execute that very fast. We can execute that very rapidly. So there's really no slowdown as the request is passing through that logic. And that's been very key for us going forward. Yeah, I think at the core, that's really what makes Varnish different than the other servers out there.
So that's interesting, because earlier you were saying that users can write VCL, and you're saying it's being compiled down to C. So that means that users are basically able to write native code to run on your edge machines?
I mean, yes, in a roundabout sort of way. There's all sorts of protections in place to prevent that from going awry. So VCL as a language is, we keep it relatively semantically limited. because that is the layer at which we can impose safety on it. If we actually let people just, inject C code into that, well, that would go awry fairly rapidly.
Right. Yeah, because it seems like, this is a incredibly multi-tenant environment. So you're saying that the restrictions that VCL has kind of prevents users from causing crashes or getting into other people's data, that sort of thing.
Yeah, exactly. But yeah, I mean, effectively every service on Fastly, every individual site is actually its own like binary blob of code. Yeah.
I guess, can you elaborate on that a little bit? Because I know, like, not necessarily in the CDN space, but in application development, some people go towards using containers. Some people have gone towards using a sandboxed runtime like V8. So I'm kind of curious what your approach looks like.
Sure. Yeah. Okay. So what our approach has looked like is, similar to what I was just describing. The advantage that something like VCL gives us is really something that comes down to performance, right? So if you were to try to spin up a new container for every request that is flowing through the system, that's really, really not scalable. That would be incredibly expensive, which would end up like translating to being incredibly expensive for your end users as well. What VCL lets us do is do that, a similar level of logic without actually having to have the overhead of something like a container or V8 as well. But we are actually exploring some interesting options. My team in particular has been working on some interesting sandboxing options. So I believe I spoke about this a couple times recently, but we're actually exploring the idea of using WebAssembly for this. And the whole point here is that WebAssembly, again, it comes back to like being able to be statically compiled. You can compile it ahead of time into very fast machine code, at which point you can then use this for every individual request as it's flowing through the system without imposing a tremendous amount of overhead, which is what you would see typically from something like V8 or worse, containers.
That's a project that you're currently working on that you hope to ship at some point in the future.
Yeah, we've been working on it for a little while now, but yeah, I've started speaking about it publicly over the last few months. It's very exciting. We've been very much looking forward to it.
What do you think are the biggest technical challenges in building a CDN?
I would say that the biggest technical challenges are actually around reliability. As I was alluding to earlier, like we have all sorts of redundancy built into each layer. And the reason, this goes so much further beyond what most sites actually have to think about. And the reason for that is that, people expect us to always, always, always be here. If a site goes down for a minute or two, that's bad. You lose some money, but if we go down for a minute or two across the entire world, that's existential threat to us.
Right.
So we put a lot of effort into making sure that we are just tremendously reliable and have redundancy built in and monitoring built in through every single layer of the system. I would say that's, having entered this arena 7.5 years ago without actually knowing a tremendous amount about it, that was the part that was probably the most surprising to me, is just how much work needs to be done to make sure that, no failure in any part of the system can actually end up affecting the entire network. It's pretty tricky. Right,
because it's almost like the equivalent of, you go down, the site goes down, just like how if AWS went down, probably a quarter of the internet would go down, that sort of thing.
Right. And in some ways, it actually is even trickier than that, right? Because, let's say we have a single data center that goes down. Well, if that data center is overloaded and then that traffic flows onto one other data center, well, what happens if that then goes down as well? It's really easy if it's not well thought through to end up being able to cause like cascading failures like that. So we have all sorts of safety in place for that. But again, it was just a lot trickier than I imagined it would be.
I can definitely see how you'd have a lot of sleepless nights thinking about that problem.
Oh, yes.
How have CDNs changed from, the days of there being basically Akamai, to having this whole landscape of players now? Honestly, the biggest change has been that move of logic to the edge. And
I mean, I don't want to toot our own horn all that much, but that didn't really exist 7.5 years ago. There's a few that, are starting to approach the problem now that you've mentioned, but that's been a pretty big change over that amount of time, right? And I think a lot of the reason for that is just that, as sites are attempting to scale, they're attempting to scale to users all over the world. They're realizing that they can make things a lot faster. They can make things a lot more reliable by moving that logic out to the edge, by moving it closer to their end users. And so that's been a pretty important change over the years. If you look back further, things have also changed quite a bit. In the early days, the early days of the internet were, when I say the early days, I'm talking about the late 90s here, was quite a bit different, right? So the approach that folks took to building CDNs back then is quite a bit different than what we do now. A lot of times what people were more worried about was, preventing requests and connections from hitting backbones on the internet. Because in those days, the backbones were actually, kind of overloaded, right? Like we have plenty of overhead of bandwidth now on the internet. That wasn't true, 15, 20 years ago. And so the approach back then to building a CDN was to, literally build thousands of data centers and put them in each individual ISP. That's not really the case anymore. It turns out that the internet has gotten quite a lot better over those years. And so the way that you build a CDN can actually be a lot more efficient now just by being able to, consolidate where you put those. And again, kind of going back to what I was saying about how we choose where our data centers go, now we get to focus on major population centers rather than having to focus on individual ISPs, which is, I must say, much nicer.
There's sort of a consolidation of power in terms of the fastest way to get to your users, which has made it, I guess, easier to create a CDN, than it would have been, let's say, the late 90s.
Yeah. I mean, I think a lot of it really comes down to just an improvement in the way that the infrastructure of the internet itself. It's not something that folks think about very often, but we have petabytes and petabytes of bandwidth going across the ocean and going around entire continents now. That wasn't the case back then.
I think you covered this a little bit before, but would you say the main place that CDNs are competing in now is in bringing more application logic to the edge? Is that where kind of a lot of the excitement is?
Yeah, I would say that is the big thing. That is the big hot topic for the next few years, in my opinion, anyway. I think we're going to see just an increased amount of, what you can do on the edge. And we're spending lots and lots of time thinking about and working on these things right now. Even down to things like, image optimization, right? Something you never would have thought to do at the edge, 5-10 years ago. You can now do that right next to your end users, which is pretty wild. And so I think a lot of what you're going to see over the next few years is people moving more and more of their logic to the edge. Not that it's ever actually going to fully replace the central cloud, the AWSs of the world, of course. There are certain things that just make more sense to be done there. But there are plenty of things that we're doing at that origin server that don't actually need to be done there. And so I'm really looking forward to it personally. I've been looking forward to it for the last 7 years.
In a lot of cases, businesses, they have to put a lot of work into handling scale. And it sounds like the hope is that developers will be able to push more of that work onto the CDN or onto the edge, rather than having to spend so much development time just focused on that.
That is the exact idea. Yeah. Let us deal with your scale problems and you focus on your business itself.
Awesome. So finally, what's next for Fastly? What can developers look forward to coming in the future?
Yeah, so I think that what we're going to be focusing on now and really continuously into the future is just making it more and more possible to do things that you never could do before at the edge. As I was just saying before, there are so many things that we do at origin servers that are actually more efficiently done out toward your actual end users. So again, that comes down to things like, security monitoring. Our web application firewall has been a big important part of that, image optimization and video modification and all sorts of things like that. There's just so much that we do with the origin servers right now that it's just not necessary. And so we're looking forward to moving more and more of that out to the edge.
Finally, are there any questions I should have asked or something you would like to say to our audience?
No, I think you've actually been very thorough, but thank you everybody for being interested in, how to build a CDN and what it takes to use a CDN effectively. Thank you.
Yeah, I think this was a great conversation. And I think there's a lot of people who, when they think of CDNs, they just think of, loading some images or loading some static assets on their site, but they don't really kind of realize the full extent of what they can do with CDN. So I think this is going to be great for a lot of people to hear.
Yeah, it's a lot different now than it was in the older days. Thank you.
Finally, how can people follow you on the internet?
You can follow me on Twitter at @TBMcMullen, or you can also email me at tyler@fastly.com.
Tyler, thank you so much for coming on the show. I think this was really great, and we covered a lot of ground here.
Great. You're very welcome, and thank you for having me.
This is Jeremy Jung for Software Engineering Radio. Thank you for listening.
DigitalOcean is the easiest cloud platform to deploy, manage, and scale applications of any size, removing infrastructure friction and providing predictability so developers and their teams can deploy faster and focus on building software that customers love. With thousands of in-depth tutorials and an active community, we provide the support you need. DigitalOcean stands out of the crowd due to its simplicity and high performance with no billing surprises. Try DigitalOcean for free by getting a $100 infrastructure credit at do.co/SERadio. Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.